Hello, I'm covering section 2.5 on equations of lines and linear models. So this is a continuation of the last section on linear functions. And last time we did the slope-intercept form. Okay, so in the last video, we did the slope-intercept form of the equation of a line. If a line has intercept y-intercept 0, b and slope m, the equation is y equals mx plus b. So this is the slope-intercept form of the equation of a line that passed through the point 0, b and has slope m. So a generalization of the slope-intercept form is the point-slope form. This is on page 234, and let me copy this. The point-slope form of the equation of a line, let me copy, that's page 234. The point-slope form of the equation of the line with slope m passing through the point x1, y1 is given as follows. Y minus y1 equals m times x minus x1. So now let's suppose that the line passes through any point, xy, or x1, y1. So you have the equation of this line. That line has slope m, and xy is any point. Okay, so the formula for the slope, that's one of the things we did in the last video. The slope is the rise over the run, so this is y minus y1 over x minus x1. So bring the denominator to the other side. And m times x minus x1 equals y minus y1. Or if we switch sides, we have the formula that we see above. Y minus y1 equals m times x minus x1. So that's the point slope form of the equation of a line. But all you need is a slope intercept form. So the slope intercept form is actually more important than the more general point slope form. So we can use either one to do this type of example, this type of exercises. Let's say we want to write an equation of the line throughout the point, passing through the point. Three, and having slope negative 1/3. Okay, so if you want, you can use the point slope form that we see above, or the slope intercept form is enough. The slope is negative 1/3. And we can just use the slope intercept form. So y is -1/3 x plus b. And we can use the point 3,3 to find b. Use 3,3 to find b. So we have what? We have that 3, or I'm going to do this. -1/3 times 3 plus b is equal to 3. But -1/3 times 3 is -1 plus b equals 3. And b is equal to 4. And the equation of the line is y equals -1/3 x plus 4. So that's the equation of the line in slope-intercept form. So in another example, so if you know the slope at any point, you can use the slope-intercept form to find the equation of a line. If you know 2 points on the line, you can also find the equation of the line in slope-intercept form. So we're going to, now we know 2 points. We're going to write the equation of the line. Passing through the points. -4, 5, and 2, 1. We're going to write the equation in standard form. The standard form is ax plus by equals c. Okay, so in any case, even if we want to write the equation of the line in standard form, we're going to find the slope first. The slope is going to be what? It's going to be 1 minus 5 over 2 minus -4. So 1 minus 5 is -4. 2 minus -4 is 6. And then -4 over 6, that simplifies as -2/3. Okay, so we're going to write in standard form. We're going to write the equation in standard form. But first, we need to write in slope-intercept form. So y is equal to -2 over 3 x plus b. We're going to use one of the points to find b. Let's take 2,1. Whatever point you take is going to give you the same value for b, but we can use, I don't see anything that is divisible by 3. So we can use the point 2,1 to find b. Okay, so -2/3 times 2 plus b is equal to 1. So -2/3 times 2 is -4/3. -4/3 plus b equals 1, and b is 1 plus 4/3. Common denominator is 3, and that is 7/3. Okay, so that's what? That's -2/3 times x plus 7/3. Okay, so that's the equation in slope-intercept form. If we want to write this in standard form, we can multiply both sides by 3. That is by the least common denominator. So 3y equals the opposite of 2x plus 7. And finally, the equation in standard form is going to be 2x plus 3y equals 7. So that's the equation of the line in standard form. Okay, and I'll do one more. I'm going to do another example like this. We are going to use the slope-intercept form, or we're going to find the equation of the line. Passing through the points 1, -1, and 3, 5. And we are going to write the equation in slope-intercept form. And standard form. Okay. Okay, so we need, no matter what, we need to find the slope. We need to know the slope and 1 point. So we can start by finding the slope. That's 5 minus -1 over 3 minus 1. 5 minus -1 is 6. 3 minus 1 is 2. So the slope is 3. Now we know that y is equal to 3x plus b. And we can use one of these points to find b. Let's take 1, -1. So 3 times 1 plus b is -1. 3 times 1 is 3. 3 plus b is -1. So b is -4. So y is equal to 3x minus 4. So that's the equation in slope-intercept form. That's part A. And in standard form, we can write this as 3x. Okay, so what we can do, we can switch places. So 3x minus y is equal to 4. So this is the slope-intercept form. And this is the standard form. Okay, next situation is to find an equation of the line from a graph. Okay, so now what we know is the graph of a line. Okay, so I'm drawing the graph of this line. Okay, so this line has intercepts -4, 0, and 0, -3. Okay, so we already know the y-intercept. So let's do that. The intercept, so we're going to, given this graph, we're going to use the graph. Use the graph to find the slope, use the graph of the linear function y equals f of x to find the slope and intercepts. We already have that. Well, we can find them quickly from the graph and write an equation that defines the function f, or write a function f of x equals mx plus b. The x-intercept is -4, 0, and the y-intercept is 0, -3. The slope is going to be a negative slope because the line is falling. So that's minus -4. So that's 0 minus -4. So that's -3 over +4. And if we want to write a linear function, y is -3 over 4 times x plus b. And we can use any of the points. I mean, we can use either the x or the y-intercept. Well, we already know the y-intercept. So just from the y-intercept, there's no need to do much. If the y-intercept is 0, -3, b must be -3. And we have the equation of a line with this graph. Well, actually, we're going to write this as a function. So actually, as a function, that's going to be f of x. And that's -3 over 4x minus 3. Okay, we have a couple of particular cases. We learned that the slope of a horizontal line is 0, and the slope of a vertical line is undefined. So we have the couple of particular cases. Any vertical line has equation x equals a, and any horizontal line has equation y equals b. Also, the slope can give you information whether two lines are parallel or perpendicular or none of that. So let's say you have parallel lines. So suppose that you have two parallel lines. You have some line L1 and another line L2. So parallel lines have the following characteristic. If you notice, they have parallel lines have the same inclination. So if they have the same inclination or the same, they have the same ratio of rise over the run, the slope must be the same. So two distinct non-vertical lines are parallel if and only if they have the same slope. So that's the case with parallel lines. And with perpendicular lines, so suppose that you have two perpendicular lines where none of them is vertical. So you have some line L1 and another line L2. And the lines are perpendicular. So they intersect at a right angle. In this case, the rise of L1 is going to be the run of L2. And the run of L2 is the opposite of the rise of L1. And the slopes are going to have the following relationship. That's also on page 237. And two lines, neither of which is vertical, are perpendicular if and only if their slope have a product of -1. Thus, the slope of perpendicular lines, neither of which is vertical, are negative reciprocals. So let's suppose that L1 has slope M1. And L2 has slope M2. Okay, so two lines are perpendicular. Neither of which is vertical. I'm not going to type that. if and only if the slopes are negative reciprocal, that is, the slope of L1 is the opposite of the reciprocal of M2, or M2 is the opposite of the reciprocal of M1, or it says if and only if their slope have a product of -1, or the product of this, by the way, M2 and M1. Okay. Okay, well, I probably need to close this board, or let's see if this fixes. Yeah, if it doesn't fix, I'm going to close it and reopen it. And let's try again. Okay, so this is where we were at. And let me share. I'm not sharing the screen. Okay, so yeah, I was making a mistake. So that was M1, or the product of M1 and M2 is -1. So that's the relationship between the slopes. Okay. So we're doing this exercise with vertical and perpendicular lines. That's number 52 on page 244. Okay, and we're doing number 52. We're going to write an equation in standard form and in slope-intercept form for each line described. Okay, the line passes through the point 3, -2, and is parallel to 2x minus y equals 5. So we're going to find the slope. Every time you want to find the equation of a line, the first step is to find the slope. And we can do this by rewriting the equation in slope-intercept form. If 2x minus y equals 5, y is 2x plus 5. So the slope of the line we want to find is 2. Okay, so the slope of the line we want to find is 2. Because we know it's parallel, we know that parallel lines have the same slope, so m is equal to 2. Okay, so we know that y is 2x. We're actually going to find this first in slope-intercept form. Y is 2x plus b, and using the point 3, -2, 2 times 3 plus b is equal to -2, or 6 plus b is -2, and b is -8. Okay. So y is 2x minus 8. This is the equation in slope-intercept form. Or 2x minus y equals 8. That's the equation in standard form. 2x minus y equals 8. Okay, the first one is the slope-intercept form. And the second one is the standard form. And we are going to answer the same question for number 54. Okay, so remember the question. Write an equation in standard form and in slope-intercept form for each line described. So actually what I did, I first did part B and then part A in the first example. And we're going to do the same. So the first step is to find the slope. Okay, so let's write in slope-intercept form. 3y equals 8x minus 7. And solve for y, so y is 8 over 3 minus 7, 8 over 3x minus 7 over 3. Okay, so I know that the slope is 8 over 3. Perpendicular lines have slopes that are negative reciprocals to each other, and the slope of the line we want to find is negative 3 over 8. Okay, so now we know that the equation of the line has the form negative 3 over 8 times x plus b. Use the point 2 comma 0, negative 2 comma 0, and negative 3 over 8 times negative 2 plus b is equal to 0. But negative 3 over 8 times negative 2, we can simplify the 2 and the 4. And negative 3 over 4 plus b is 0. And b is 3 over 4. And that's it. Okay, just making sure this. Okay, I'm actually there's a minus, so this is positive. Yeah, I have a couple of minuses, and this is negative. Once we solve for b, this becomes negative. Okay, so first they are asking us for the slope-intercept form. The slope-intercept form is y equals minus 3 over 8 x minus 3 over 4. And the standard form, we can multiply both sides by the least common denominator. In this case is 4, so that's going to be 8. Okay, so that's 8y equal to 8 times the opposite of 3 over 8x minus 3 over 4. And the reason I'm doing this is to keep everything with integers, to avoid fractions as much as possible. 8y, it's the opposite of 3x minus 6. So 8 over 4 is 2. 2 times -3 is -6. And 3x plus 8y is -6. Okay, so this is the first one is the slope-intercept form. And the second one is the standard form. So I'm doing a couple of applications to finish this section. We're doing number 61. We're using the figure in that problem. So that's number 61. So on the same page, but we need the graph. Okay, so that refers to example 7. I'm going to find that to copy this for you. Okay, so we have this table and the graph. Okay, so refer to the table that accompanies figure 49 in example 7. Okay, for this matter, you want to, we can read this example to know what they are talking about, to have some context. Okay, so this table and graph represent the average annual tuition and fees for in-state students at public four-year colleges, which is, by the way, is not the case of Brunel, but it's a good exercise. So the average annual tuition and fees for in-state students at public four-year colleges are shown in the table for selected years and graphed as ordered pair of points in the figure on the right, where x equals 9 represents 2009, x equals 1 represents 2010, and so on. And y represents the cost in dollars. So this graph of ordered pairs of data is a scatter diagram. So now that we have some context, we're going to use the data points 0, 6,312, and 3, 7,703 to find a linear equation that models the data. So let's do that. Our points are 0, 6312, and 3, 7,703. Good thing we already know the y-intercept. So we already know the y-intercept. All we need is the slope. So that's what? That's 7703 minus 6312 divided by 3, which is 1,391 divided by 3. And that's approximately, if we round to the nearest 100, that's 463.67. The equation of the line is then y equals 463.67 x plus, we know the y-intercept, that's 6,312. So that's part 1. Part 2, or Part B, use the equation from Part A to estimate average tuition and fees for in-state students at public 4-year colleges in 2013. And how does the result compare to the actual figure given in the table, 8070? So 2013 corresponds to x equals 4. So 2013 is 4 years later. So we're going to plug it in. And that's going to be, once you calculate that, that's going to be $8,166 with 68 cents. So actually the estimate is close enough. The estimate is close enough to the actual value of 8,070. And I'm doing one last example on temperature conversion. Okay, so let me copy that. That's number 65. Okay. So I'm copying the problem. And there it is. That's on page 246. When the Celsius temperature is 0 degrees, the corresponding Fahrenheit temperature is 32 degrees. When the Celsius temperature is 100, the corresponding Fahrenheit temperature is 212 degrees. Let C represent the Celsius temperature and F represent the Fahrenheit temperature. We're going to express F as an exact linear function of C. So this is what we want. We're going to let Fahrenheit be some function of C. Or if it's an exact linear function, that's going to be M C plus some value B. Okay, but we know more information. Says that when the Celsius temperature is 0 degrees, the Fahrenheit temperature is 32 degrees. So we can get the first pair of points, 0, 32. And when the Celsius temperature is 100, the corresponding Fahrenheit temperature is 212. Okay, so we have these 2 points. Not only that, we know the, let's call this the vertical intercept. The vertical intercept, or the F-intercept, is 0,32. And the slope is 212 minus 32 over 100 minus 0. So that's 180 over 100. Let's simplify the fraction. Most of the time, this is written as a fraction. So they are divisible by 20. 180 over 20 is 9, and 100 over 20 is 5. And the slope is 9/5. Okay, so the function is going to be 9 over 5c plus 32. B, solve this equation in part A for c, thus expressing c as a function of f. Okay, so we're going to solve for c. So solving for c, subtract 32 from both sides. And then multiply by the reciprocal. So 5/9. And 5 over 9c, or 5 over 9 times f minus 32 is equal to c. Or you want, c is 5 over 9 times f minus 32. And we can just keep it like that. Or if you want to write in slope intercept form, that's okay. But that's not necessarily going to be simpler. So that one is fine. We can leave it like that. And C, for what temperature is F equals C a true statement? Okay, so part C. For what value is F equal to C? Okay, so what we can do, we can plug it into any of the equation. Let's say we let F equal C. So we plug this into the first equation. We can see that C is 9 over 5 times C plus 32. We're going to solve this for C. Okay, this equation involves fraction. You want to avoid fractions at all, you can just multiply by the least common denominator, which is 5. And 5c equals 9c plus 32 times 5 is 160. Subtract 9 from both sides, 9c from both sides, and negative the opposite of 4c is 160. And dividing by 4, c is 100. C is negative 40. Okay, so that's going to be the answer. Both Celsius and both scales, Celsius and Fahrenheit, are equal when they're above 40. So negative 40 Celsius degrees is equal to negative 40 Fahrenheit degrees. So with this, we cover section 2.6, equations of lines and applications. And thank you for listening.